In this presentation, we're going to look at the Spearman Rank correlation, a rank-based correlation coefficient that is calculated using the rankings rather than the actual values of some sort of test. So here we have a couple of items A, B, C, and we have two sets of rankings. So these might be students and two exams or something like that. Student A comes first in test 1 and second in test 2 and so on. Student B comes 7th in test 1 and 8th in test 2. Or it might be two sports teams or sports competitors in two different competitions or something like that. What we're going to do is sort of consider the strength of association between ranking 1 and ranking 2. So if there's a high degree of association, low values will be in ranking 1 will be associated with low values in ranking 2, and conversely high rankings in ranking 1 will be associated with high rankings in ranking 2. Just importantly here, there is no tied values here. There is no tied rankings in this presentation. I will do a separate presentation where tied rankings are allowed, and I'll show you what to do when you have tied rankings. So let's move on. So here's the formula there, the formula for Spearman's rank correlation coefficient, R subscript S. And again, this is a formula is for when there's no tied rankings. R of S, the subscript S, is to denote that it's Spearman's rank correlation rather than Pearson. So just make a note of that there. That's why we have that subscript S. 1 minus this fraction here, 6 times the sum of D squared. D is the case-wise differences for each ranking. Divide that by N times N squared minus 1. So that's based on the number of items or number of cases. So what we're going to do is fill out this table here. We have the case-wise differences, and what we're going to do is compute the case-wise differences, square them, and later on we're going to sum them up. We're going to pick a direction, so we're going to have ranking 1 minus ranking 2. If we have a direction, just stick with it. So 1 minus 2, we get minus 1. Square that, we get 1. 7 minus 8, minus 1. Square that, we get 1. 6 minus 4, we get 2. Square that, we get 4. 2 minus 1 is plus 1, square that we get 1. 4 minus 5 minus 1, when we square that we get 1. 3 minus 3, 0, 0. 5 minus 6, 1, or minus 1 and 1. Minus 1 and 1 again. And lastly, 9 minus 7, that's 2, so when we square that we get 4. So what we're going to do now is sum up all the values in the last column there. So we're just going to sum up all those values there. And 1, 1 plus 4 plus 1 plus 1, that's 8 so far. 1, 1 and 4, that's 14 altogether. So 14. So just to confirm, this is what we should be looking at here. And moving on, so what we have now is we have the sum of D squared is 14, the number of cases is 9. So just working this bit out here, n times n squared minus 1, we're just going to look at that bit there. Actually, let's do it all here. So 6 times the sum of D squared is equal to 6 times 14, that is equal to 84. N squared, n times n squared minus 1, that's 9 times 80, that's 720. Okay, so that's a few values there that we, that's actually most of the calculation carried out. All I have to do now is finish it off. So RS equals 1 minus 84 divided by 720. That is equal to 1 minus 0.1166, and that is equal to 0.8833. So you could just express it to two decimal places. RS equals 0.88. And that ends our presentation.